Hi children, how are you? Yes, I hope all are fine. Yes, very good. So today we are going to see about in chemical bonding is unit number 13. Okay. So in the last previous class we see about is what is molecule and then types of chemical bonding. Yes, that chemical bonding is ionic bond and covalent bond and coordinate bond and metallic bond. This is all strong bond. Then another one topic is Coastal-Lewis approaches of chemical bond. Yes, so now we are going to discuss about in ionic bond characteristics. Okay, ionic bond characteristic. So what is ionic bond? Yes, the ions mean the positive and negative charges is one electron is lost and one electron is gained. We get the positive charge and the negative charge is called the ionic bond. The formation of ion is ionic bond. So in the example is sodium chloride and another one of the example is magnesium chloride. Yes. So now the next topic is characteristics of ionic bond. Okay, the characteristics of ionic bond. So the nature of bonding between the atoms of a molecule is the primary factor that determine the properties of compounds. So in the properties of compounds is depends on the bond. Okay, the properties of compounds is depends on the bond. So next one, the atom are held together by a strong electrostatic force. So the strong electrostatic force means in the positive and negative charge. Okay, in the positive and negative charge attraction in the formation of bond. So the strong electrostatic force that makes the compound to have the characteristic features is the following features. So the first one, physical state and electrical conductivity and melting point and solubility and density, hardness and brittleness and the reaction. So the first one is the physical state. So in the physical nature in ionic compound, okay, so the ionic compound are solid and hard safe. So the ionic compound are solid and hard because of the strong force of attraction. A strong force of attraction between the which charges? Yes, negative charges and positive charges. So these compounds are broken into pieces when pressure is applied. So this is the physical state or physical nature of ionic compound. Then electrical conductivity. So in the electrical conductivity, so take you one beaker. It contains in salt solution. So the salt solution means sodium chloride solution, and insert the electrodes. So the electrodes in positive and negative uh, electrodes is the name is cathode and electrode. When pass the electricity and current and observe the conduction of electricity. So through the solution that involves the movement of ions. So in the sodium positive ions and chloride is negative ions of charged particles towards the opposite electrodes. So in the positive charge is collected in the anion is the negatively charged and then negatively charged particles is collected in the cathode is cathode rod is the positive charged ions. So in the positive ion is attract to the negative charge. So in the negative ion is attract to the positive charges. So this is the electrical conductivity. The next one is the melting point. So ionic compounds are high melting and high boiling point because the high amount of energy is required to break the strong interionic attractions. Okay, so the melting point and boiling point is high melting point and boiling point is ionic compound. Then the solubility. So in the ionic compound, okay, ionic compound like sodium chloride and potassium iodide are soluble in water and insoluble solvent like kerosene and petrol. So in your book exercise in the ionic compound are soluble in the polar solvent like water. So water is a universal solvent. So the insoluble non-polar solvent like benzene and carbon tetrachloride. The next one is the density, hardness and brightness. So the ionic compounds have high density uh, and they are quite hard because the strong electrostatic force of attraction between the ions. So ions is nothing. Ions is positive and negative charges of ions. So they highly brittle. Then the reactions. So the ionic compounds undergo the ionic reaction is instantaneous reaction, is the immediate reaction. So the sodium and chloride and then added with the water, it is insoluble, it is soluble reaction. The reaction is immediate reaction, so it is called the instantaneous reaction. So the next bond is covalent bond. So in the covalent bond is sharing of electrons. So in the ionic bond and compared with the covalent bond. So the ionic bond in the last outermost valence shell in the excess of one electron is removed and then less than one electron is gain of one electron. So this concept is the ionic bond. So in the covalent bond is in the last outermost cell of valence shell electron is greater than one electron and less than one electron. So one atom is greater than one electron, another one atom is less than one electron. So that electron is sharing. Okay, that electron is shared together. So the atoms can combine with each other by sharing the unpaired electrons. Okay, sharing the unpaired electron. So in the last valence shell electron present in 8 electrons. So 8 electrons means 4 pair of electrons. So in the pair electrons means one pair is 2 electrons, so 4 pairs of electron. So unpaired electron is balanced electron. So in the sharing of unpaired electrons in their outermost shell. So the according to Lewis concept, when the two atoms from a covalent bond between them, the atoms attain the stable electronic configuration of the nearest noble gas. In the same topic, the nearest noble gases. So for example, hydrogen atomic number 1. Yes, hydrogen atomic number 1. Then electronic configuration 1s2. Then helium atomic number 2. Then electronic configuration is 1s2. Okay, so the hydrogen is 1s1. So one electron is unstable. So stable electrons means in the first layer presence of 2 electrons is completely filled. So hydrogen is one atom. Okay, hydrogen is one atom. Then remaining one more hydrogen is added. H and H2 is molecules. Okay, H2 is molecules. So one hydrogen and another one of one hydrogen. So these two hydrogens are sharing of electrons. Okay, these two hydrogens are sharing of electrons. So create one bond. So this bond is called covalent bond. So the sharing of electron which become common to both the atoms, it is also called atomic bond. Okay, so the covalent bond is otherwise called atomic bond. So the formation of covalent bond. So in the formation of covalent bond, so let us consider the two atom. One is A and another one is B. So A atom is less than one electron and B atom is greater than one electron in the outermost valence shell. So these electrons are shared pair of electrons in the atom A and B. So the bond is formed, so that bond is covalent bond. Okay, So the electron pair. So the electron pair and the pair of electron filled in the outer shell of both the atoms. So completely filled the valence shell electronic configuration. It is the stable one. So next one is the examples. Is the illustration one, the formation of hydrogen molecule. So atom means presence of one element. So atom means presence of one element. Element means one hydrogen. So one or two element is the same element is combined to create the bond is molecule. Okay, so a molecule is a natural group of two or more atoms. Okay, a molecule is a natural group of two or more atoms held together by chemical bond. So first example, molecule of hydrogen. So already I say hydrogen, the atomic number 1, then the first shell. Okay, in the first shell, hydrogen atomic number 1, then the, so all of you write the electronic configuration. Hydrogen atomic number 1 and the electronic configuration 1 as 1. Okay, so one hydrogen is 1 as 1, then another hydrogen is 1 as 1. So it in this cell is incomplete shell. Okay, in this cell is incomplete shell. So the two electrons are shared. Okay, two electrons are shared the electron pair. So each hydrogen two electron. Okay, each hydrogen. So this hydrogen is have two electron, then another hydrogen have two electron. So two hydrogen atom. Okay, two hydrogen atom combine to form hydrogen molecules. Okay, so this bond is covalent bond. Then the second example is chlorine molecule. Okay, chlorine molecule. So chlorine is the atomic number 17. Then the electronic configuration is 287. So three shell is formed with chlorine. So in the first cell is filled 1 as 2. Then the second cell is filled 2s2 and 2p6, total 8. Okay, so in the second shell is 8 electrons are filled. Then the third cell 3s2 and 3p6, 8 shell. Okay, but one chlorine is less than 1 electron. Okay, one chlorine is less than 1 electron in the third shell. So in the next chlorine atom shell, in the same less than 1 electron in the third cell. So in the electron, so one electron is sharing. Okay, one electron is both sharing of one electron. So shared pair of electrons to create the bond. Okay, to the formation of the bond. That bond is covalent bond. Okay, so this rule is obey the octet rule. So in the last layer the presence of 8 electrons, so this is the octet and 8 rule of 8. So in the last layer of the electrons is 8 electrons, so it is the completely filled and stable electronic configuration. So the sharing of electron to create a covalent bond. Okay, this is the chlorine molecule. Then next one is methane molecule. Methane formula is CH4. Okay, CH4, methane. So one carbon atom and 4 hydrogen atom. Okay, one carbon atom and 4 hydrogen atom. So carbon atomic number 6. Okay, carbon atomic number 6, but the electronic configuration 2 and 4. So in the first layer 2 electron and then second valence electron is 4 electrons too. So 2 and 4, carbon valence electron 4. Okay, then hydrogen valence electron is 1, but 4 hydrogens are present, CH4. So 4 hydrogens are present. So one hydrogen have one valence electron. So 4 hydrogen is 4 valence electrons are present. So in the formation of, so carbon atom is first layer is completely filled and then second layer is not completed, 4 valence electrons. Okay, so in the hydrogen, 4 hydrogen atoms, so each hydrogen atom presence of 1 electron. So in this 1 electrons is sharing of the carbon atom. Okay, sharing of carbon, so create a carbon to hydrogen chain. Okay, create a carbon to hydrogen bond. So this bond formation is covalent bond of methane molecule. Okay, so methane formula is CH4. Okay, the next one is the formation of oxygen O2 molecule. So molecule means one or more atom is combined. Okay, one or more atom is combined. So the oxygen molecule, so the oxygen atomic number is 8. Oxygen atomic number 8. Then the valence electron is 6. Okay, so one oxygen atom is 6 electrons. So in the sharing of electrons is 2 electrons. So the sharing of electrons is 2 electrons. So 2 sharing of electron to form the covalent bond, to create a 2 bond. Okay, because in hydrogen and chlorine and methane molecule is sharing of electron in 1 electron, so create the formation of covalent bond in 1 bond. But oxygen 2 sharing of electrons, so formation of bond in 2 covalent bond. Okay, formation of bond is 2 covalent bond. The next one is the formation of nitrogen molecule. Is the formation of nitrogen molecule. So nitrogen is the atomic number is 7. Okay, nitrogen atomic number is 7. So first cell is completely filled with 2 electrons. Then the second cell is incomplete the electrons because 5 electrons only present. Is 8 electrons is completed, 5 electrons means incompleted. So in the nitrogen N2, N and N is separately draw the ionic structure. So in the 3 electrons is shared. In the 3 electrons is shared. So the bond formation is 3 bond. Nitrogen triple bond nitrogen. Okay, oxygen double bond oxygen, then nitrogen triple bond nitrogen. So this is the covalent bond, single bond, double bond and triple bond formation of covalent bond with the sharing of electrons, So the next one is the characteristics of covalent bond. Okay, characteristics of covalent bond. So these characteristics, this first one is solid state and electrical conductivity and melting point and solubility and hardness and brittleness and the reactions. Okay, so in the first one is the physical state. So in the physical state means what is the physical state? So in the gaseous state and the liquid state and then solid state. So these are the physical status. So physical state is depend upon the force of attraction between the covalent bond. The bond is weak bond or strong bond. Okay, so this is the physical state of covalent bond. Then the covalent compound is the gaseous state, liquid state and the solid state. For example, the solid state example is diamond and liquid state example is water and gaseous state example is oxygen. So the physical state is, so first you identify the bond is solid, liquid and gaseous. Then the force of attraction between the strong bond or weak bond. Then the electrical conductivity. So in the covalent compound is do not contain the charged particles. Do not contain the charged particles. So ionic compound only charged particles is negative ion and positive, negative charge and positive charge. So the covalent compound is do not contain the charged particles. So the electrical conductivity is very bad. Then the melting point. So in the melting point is low melting point and boiling point. So it is the low melting point is compared to the ionic compound. Then the solubility. So in the solubility is soluble in non-polar solvent. Okay, so the ionic compound is soluble in polar solvent like water, and in non-polar solvent soluble in benzene and carbon tetrachloride. But the solubility of covalent compound, the covalent compound is soluble in non-polar solvents. That non-polar solvent is like benzene and carbon tetrachloride. So that polar solvent like is water. They are the insoluble in polar solvent is like water. Then the hardness and brittleness. The covalent compound are neither hard or brittle. So but they are soft and waxy. So this is the hardness and brittleness. Then the reaction. So the reaction is very slow reaction. So the ionic compound reaction is instantaneous reaction. The covalent bond reaction is slow reaction. Okay, so this is the characteristics of covalent compound. Fajan's rules. So in this rule is metal and non-metals is combined in the ionic bond. Okay, so one structure. So in this structure is sodium is metal and chlorine is non-metal. Okay, then the aluminium and fluorine and chlorine and bromine is a non-metal. So one metal is combined to the non-metals. So this rule is called Fajan's rule. So in this rule is related to the charge separation of ionic compounds. So the ionic compounds means two or more atoms is combined in the charges. So one is positive charge and another one is negatively charged. For example, is sodium chloride. Sodium get positive charge and chlorine get negative charge. And then another one, magnesium chloride. So magnesium is positive charge and chlorine is negative charge. Then aluminium chloride. So aluminium is positive charge and chlorine is negative charge. So the next one is aluminium fluoride. So aluminium positive, fluorine negative. Then aluminium chloride, then aluminium bromide. So aluminium positive, chlorine and bromine is negative ions. So this Fajan's rule is relative to the charge separation. Okay, negative charge and positive charge is separated. So the charge separation of ionic compound. Okay, so a metal combines with a non-metal through the ionic bond. So the ionic compound is formed or this called ionic compound. So the charge of cation and anion. Okay, the charge of cation and anion are completely separated. So the red mark and blue mark. So the red is all atom is positive charge and blue is all atom is negatively charged. So the separation of positive charge and negative charge. So in this rule is found in Fajan. So it is called Fajan's rule. So this rule is through the X-ray crystallographics studies about the X-ray crystallographics. So the ionic compound is show the covalent character. So this rules to predict whether a chemical bond is ionic or covalent. So some differentiation of ionic and covalent compound. So the ionic compound have low positive charges and covalent character has high positive charges. So see the diagram. So in the positive charges are in smaller size. Positive charges are in the smaller size and negative charge in the large size. So in the ionic compound size is low positive charge and covalent compound is high positive charge. Then the ionic compound is large cation and small anion. Okay, large cation and small anion. Then the covalent compound is small cation and large anion. Okay, small cation and large anion. So for an example is sodium chloride. Okay, sodium chloride. So sodium chloride is low positive charge. So the sodium is only plus charge. Okay. So the magnesium chloride, magnesium 2 charge. So 2 means 2 loss of electrons. Okay, 2 plus means 2 loss of electrons. 1 means 1 loss of electrons. Okay, so the sodium plus is low positive charge plus 1. So in the large cation is add relative to small cation. Sorry, small anion. So in the large cation is relatively small anion. So this is the ionic separated completely is the ionic formation. Then the aluminium triiodide is the aluminium triiodide. So in the aluminium is get positive charge of 3. So in the last one aluminium chloride Al3 plus and Cl minus. So Al3 plus. So 3 plus means 3 ions are less. So less 3 loss of electrons. So 1 losses of electron is plus 1, 2 losses of electrons is plus 3, plus 2 and 3 losses of electrons is plus 3. Okay, so the aluminium triiodide is higher is positive charge plus 3. So the large of the anion, okay, large of the anion is no complete. Okay, no complete the charges. So the iodide means is chlorine. Okay, so is aluminium chloride. Okay, aluminium chloride and aluminium bromide is not separated. Okay, is not separated. So is the large of anion and thus no complete the charge separation. It is called covalent bond. So the ionic formation means is completely separate the charges, and covalent character means is does not separated. It does not separated the charge of atoms. So this is called the Fajon's rules. So today we are study about the ionic compound of characteristics of ionic compound and covalent bond, and then examples of covalent bond, and then characteristics of covalent bond and Fajon's rules. Okay, so all of you study. So your homework. So all of you write in the covalent bond. Okay, so what is covalent bond and any one examples. Okay, any one examples and one more examples. So all of you write in your homework note. So in your example is nitrogen. Okay, nitrogen 3. Okay, nitrogen 3, the formation of nitrogen 3 example. Example in nitrogen and methane. Okay, methane CH4. So first you write the what is covalent bond, and then example of methane and nitrogen, and then what is Fajon's rules and Fajon's rules diagram. Okay, so next another one of the homework is, so in your book page number 142 in the periodic table. Yes, so in the periodic table first hydrogen to 30 zinc. Okay, zinc element. So in the zinc element is draw the atomic structure diagram. Okay, draw the atomic structure diagram. So in the first one hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Okay, then aluminum, silicon, phosphorus, sulfur, chlorine, argon, then potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt and nickel, copper and zinc. So in the 3 elements, so first you write the element name an atomic number. Okay, so the separate column atomic number and then electronic configuration. So in the electronic configuration and then atomic structure diagram. So that diagram is in the first layer, second layer and third layer in the filled electrons. Okay, so this is your homework. Okay children, thank you.